55. That is how many kilometers per year Earth's magnetic North Pole was traveling at its peak, a full sprint by the standards of a planet. For nearly 2 centuries, it had crawled through the Canadian Arctic. Then, within a single generation, it bolted across the Arctic Ocean, past the top of the world, and as of the newest official map, closer to Siberia than to Canada, for the first time ever measured, into waters no instrument has ever tracked it through. And then it did something stranger. It slammed the brakes, the largest slowdown in pole speed ever recorded. Scientists cannot fully explain the sprint, they cannot fully explain the brake, and the map of all of it is sitting in your phone right now. By the end of this video, you will know what the field is actually doing and where the real danger lies. December 2024. 2 agencies, NOAA's National Centers for Environmental Information in America and the British Geological Survey, publish a document most people have never heard of and nearly all of them carry: the World Magnetic Model. This was not a research paper. It was an operational update pushed to nearly every navigation system on Earth. The update's headline is an address. It places the magnetic North Pole at 86.38 degrees north, 164.06 degrees east, out over the central Arctic Ocean, within a few hundred miles of the geographic pole. And that address carries a milestone. For the first time since tracking began, magnetic north sits closer to Siberia than to Canada. After nearly 2 centuries as a Canadian resident, it now sits on the Russian side. In high-latitude ocean, modern measurements have never seen it occupy unmapped territory. In the most literal sense this science allows. 2 definitions carry the rest of this story. Geographic north is fixed, the point where Earth's spin axis meets the surface. Magnetic north is not. It is wherever the planet's field lines dive vertically into the ground, and it moves. The angle between the two is called declination, and correcting for it is the entire job of the World Magnetic Model, the reference for aircraft, ships, submarines, militaries, and the compass in virtually every smartphone. When the pole moves, that correction changes everywhere on Earth. The release also carried a first-ever high-resolution edition and freshly drawn blackout zones near the pole's regions where a compass simply cannot be trusted. Routine housekeeping on the surface. But a new address is only routine if the journey was, and the pole did not stroll to this one. For 30 years it ran. 1,831. In the Canadian Arctic archipelago, explorer James Clark Ross watches his dip needle point straight down. He has found the first measured position of magnetic north. For most of the century and a half that follows, the pole ambles through Arctic Canada at roughly 10 to 15 kilometers a year, slow enough that a chart could age for decades and still tell the truth. Then, in the late 20th century, something under the planet shifts gears. By the 1990s, the pole is leaving Canada entirely, striking out across the Arctic Ocean, and through the 2000s and 2010s. It hits a full sprint, peak speeds near 55 to 60 kilometers a year. Several times its historical pace unprecedented. A point that had crawled for generations was now covering more ground in 1 year than it once managed in 5. The sprint had consequences. The World Magnetic Model is rebuilt every 5 years, its makers forecasting the pole's drift across each cycle. In 2019, the pole made those forecasts obsolete. It had moved so much faster than predicted that the model's errors were approaching operational limits, and for the only time in its history, the model was reissued a year early, off schedule. An emergency patch, quietly pushed to the navigation software of the world because the planet had outrun the paperwork. And then came the strangest entry in the whole record. Over the past 5 years, the sprint broke. The pole's speed collapsed from around 50 kilometers a year to roughly 35, a slowdown. The British Geological Survey's own Geomagnetic modeler described as the biggest deceleration in pole speed ever seen. Not a gentle easing. A snap as abrupt in this data as the acceleration had been. To be clear about scale, 35 kilometers a year is still blistering by any pre-1990 standard, but it now moves to a rhythm nobody predicted in either direction. The models missed the sprint, the models missed the brake. 2 mysteries, 1 engine. And the engine sits 2,900 kilometers under your feet. Travel downward through the crust, then through nearly 2,900 kilometers of slowly creeping mantle rock until the floor drops away into something no drill, camera, or probe has ever touched. An ocean of molten iron and nickel, thousands of kilometers deep, approaching the temperature of the sun's surface. That ocean is churning. Heat escaping the planet's center drives its liquid metal in vast, slow convection currents, and moving liquid metal is a moving electrical conductor. The result is an electric generator the size of a planet. Scientists call it the geodynamo, and its output is the magnetic field wrapped around everything you have ever done. This is why the pole wanders. Earth's field is not a bar magnet frozen in the core. It is the surface expression of that churning fluid, and when the flow down there reorganizes, the field above reorganizes with it, dragging the pole wherever the new geometry points. It is also why the field matters beyond compasses. That magnetic envelope is the shield, the structure that deflects the solar wind and absorbs the flare-driven storms this channel has covered all year. Every geomagnetic storm forecast begins with this field's shape. And here is the humbling part. No human instrument has ever observed the core directly. Satellites read the field from orbit. Observatories read it from the ground. Everything we know about the engine is inference from the field it throws upward. We map the machine by its exhaust. So when the pole sprints, something down there changed. The leading explanation is a tug-of-war, and one side is winning. What drags a magnetic pole across an ocean? Zoom the field maps in on the core's outer boundary, and the answer takes shape as two enormous patches of concentrated magnetic intensity flux lobes in the trade, one anchored beneath Canada, one beneath Siberia. Between them, the North Magnetic Pole sits like the marker in a tug-of-war. For decades, the measurements have shown the contest turning one-sided, the field over Canada weakening, the field over Siberia strengthening. And as geophysicists at the British Survey describe it, that growing imbalance is what pulls the pole toward Siberia. The pole is not wandering, it is being dragged by a shift in the weight of the field itself. Now, the part this channel insists on saying plainly: why did the flow in the core reorganize to produce a 30-year sprint? Unexplained. Why did it then produce the biggest break ever measured? Also unexplained. The scientists who maintain the world's magnetic map use two words for the field's behavior: complicated and chaotic. There are candidate influences on the table, changing circulation patterns in the molten iron, deep waves rippling through the core's fluid, even interactions with solar activity at the field's outer edge. Every one of them is a proposal. None of them is a verdict. The honest state of the science is that humanity watched the pole change speed twice, dramatically, and can describe the change far better than it can explain it. And the mystery deepens at the other end of the planet. While the North Pole sprinted, braked, and crossed hemispheres, the South Magnetic Pole barely stirred, drifting off the coast of Antarctica at a sleepy 5 to 10 kilometers a year, as it has for decades. Same planet, same molten engine, two entirely different tempers. Whatever reorganized under the Arctic did not reorganize under the Antarctic, a lopsidedness that is itself a clue about how local and how strange the core's behavior can be. The geometry has even produced a small landmark for this very year. The British Survey's modelers projected that in early 2026, as the North Pole slides towards Siberia, the two magnetic poles would briefly share the same line of longitude, an alignment that has probably not occurred in many centuries. Nothing physical follows from it, but it is a measurable milestone on a journey nobody scripted. So assemble what is on the table. A global field that has weakened by nearly a tenth in 2 centuries. A pole that sprinted like never before, then braked like never before, for reasons no one can state. A shield with a soft spot already growing over the South Atlantic. Line those up, and a certain corner of the internet arrives at one conclusion very quickly. The poles are getting ready to flip, and the shield is failing on schedule. That claim has ingredients, real ones, which is exactly why it deserves the full treatment. So put the flip on the table. But first, check the patient's actual vitals. Now, line up the vitals. Vital 1. Strength. Over the past 2 centuries, Earth's magnetic field has weakened by almost 10%. Say it precisely, though the loss is not uniform. The field has thinned over Canada while strengthening over Siberia, and that lopsided ledger is the very imbalance dragging the pole east. The planet is not simply losing field, it is redistributing it. Vital 2. The dent. Over the South Atlantic sits a region where the field's strength runs anomalously low, the South Atlantic anomaly. It has been observed for centuries, and over the past 100 years its weakest point has drifted steadily westward, from southern Africa toward Brazil. The consequence is not theoretical. In that region, the thin shield lets high-energy particles from space dip closer to the planet, and low-orbiting satellites crossing it pay the toll. Electronics glitch, instruments flip into protective safe modes, and operators plan their spacecraft's days around the crossing. Even the Hubble telescope was long programmed to idle its instruments while passing through. The dent in the shield has a maintenance cost, and it is already being paid. Vital 3. The dependencies. The model built on this field is not a curiosity, it is the navigation reference for the American and British defense establishments, for NATO, for civil aviation and shipping, for submarines running where satellite signals cannot reach, and for the compass chip in effectively every smartphone on Earth. And near the poles, the newest edition draws explicit blackout zones, regions where the field's geometry makes magnetic navigation flatly untrustworthy. The map now marks its own dead ends. Vital 4. The stress test already on the record. 2019 the year. The pole outran the 5-year forecast badly enough to force the only emergency update in the model's history. The system bent, patched itself, and held. But it learned its own prediction horizon the hard way, and the lesson stands: this field can move faster than its forecast. Read the chart honestly, and no single vital is an alarm. Together, they describe something specific, a field that is changing faster than it is being predicted, a patient whose chart keeps surprising the doctors, not dying, but not behaving. Which brings us to the claim itself. Let us take it seriously, and then let us look at what the record actually shows. Here is the most honest version of that fear, the version that doesn't need a single invented fact. Magnetic reversals are real. The rock record shows Earth's poles have traded places hundreds of times across deep history. The last full swap came roughly 780,000 years ago. And between the flips sit the excursions, partial collapses like the Lachamps event, about 41,000 years ago, when the field appears to have fallen to a small fraction of its strength before recovering, an episode whose atmospheric and biological side effects remain an active field of research. Now hold today's chart beside that history. The field is measurably weakening. The pole just spent 30 years behaving unlike anything in the instrument record, then broke pattern again. The shield already carries a working dent that satellites pay for on every orbit. The weakening is a measurement. The sprint is a measurement. The dent is a measurement. Stack them, and the flip hypothesis stops sounding like a fringe fever dream and starts sounding like pattern recognition. And unlike most internet fears this channel has tested, this one is built entirely from peer-reviewed parts. Now the verdict, in 2 parts. Part 1, ask the people who actually built the map. The scientists behind the 2025 model state it without hedging. The model shows no sign of an impending reversal. And the shape of a real reversal matters. Full flips unfold across thousands of years, not within a human lifetime. Nobody alive would watch one from start to finish, even if it began today. As for the numbers driving the fear, a 10% decline over 2 centuries, a wandering pole, the deep record puts them in their place. The field has strayed further, weakened more, and wandered stranger many times in its history without flipping. By the standards of that record, today's field is not unusually weak. 10% down over 200 years still leaves a shield doing its job. The auroras you watched in our solar coverage are that shield, working. And the most popular version of the fear we're overdue fails on its own arithmetic. Reversal intervals are wildly irregular, ranging from tens of thousands of years to tens of millions. There is no schedule. A clock with no hands cannot run late. Part 2 is the honest residual, and it is the thread running through every investigation on this channel. The deceleration is genuinely unexplained, the field keeps doing things its models must chase, and 2019 stands as proof that it can outrun a 5-year forecast badly enough to force an emergency. The South Atlantic dent is not a hypothesis, it is a present-tense operational bill, evolving on timescales of decades and centuries. And beneath both sits the deepest limit of all. Humanity maps this engine in 5-year snapshots, from the outside, in arrears. We can name the system in exquisite detail. We cannot name its next move. It is the same shape of problem as the sun's flares, the typhoon's ignition, the fault's failure hour watched perfectly, predicted poorly. The difference here is only the clock flares resolve in minutes, storms in days, the core in centuries. So the verdict cuts clean. Nothing in the data says a flip is beginning, the map's own makers say so, and the deep record backs them. But everything in the data says the engine is livelier than its maps. That gap has a name in every field this channel covers. The prediction horizon. Here, it is 5 years against a machine that thinks in millennia. If something deserves your anxiety, it is not the poles. It is the gap between a chaotic core and a 5-year forecast of it. Because the only honest ruler for a wandering pole is deep time. Lay this era against it. The field keeps its own biography, and it writes in stone. When lava cools, its iron minerals freeze in alignment with the magnetic field of that moment, a compass needle cast in rock. When the seafloor spreads, it lays down those frozen compasses in stripes, mile after mile, a tape recording running back hundreds of millions of years. Read the tape, and the field's character emerges. The poles have traded places hundreds of times. Long, calm chapters, then a slow, sputtering swap unfolding across thousands of years, then calm again. The last full reversal finished roughly 780,000 years ago, before anatomically modern humans existed. No member of our species has ever seen one. But our ancestors did see an excursion. Around 41,000 years ago, during the Lachamps event, the field collapsed to a small fraction of its strength, wobbled, and critically recovered without flipping. Humans were alive for that. Neanderthals were alive for that. Life on Earth has in fact been alive for every reversal and every excursion in the entire tape. The shield has flickered many times. The biosphere is still here. Now lay our instrument era against that tape. 1,831 to today. Not yet 2 centuries of direct measurement against hundreds of millions of years of recorded field. A rounding error. 2 pages, torn from a library. And inside our rounding error, 2,200 kilometers of drift, an unprecedented sprint, a record break, a change of hemispheres. The fastest chapter humans have ever watched, and, quite possibly, perfectly ordinary on timescales we have simply never sampled. The field has done far stranger things than anything in our 2 centuries of notebooks. We just were not there to be surprised. So deep time counsels 2 things at once. Calm about the flip the tape says these are slow, rare events with no schedule, and the biosphere has outlived everyone. And humility about our confidence. The tape also says our sample of this machine's behavior is laughably short, which is why the scientists do not sit watching for a flip. They watch the chart. So here is the chart, and the handful of numbers on it actually worth your attention. So, where does this leave us? Watching 4 numbers, none of which is a countdown. Number 1, the speedometer. The pole currently reads about 35 kilometers a year, and the only honest forecast is that nobody has one. 35 could be a new cruising speed, a pause before another sprint, or the start of a long descent toward the old crawl. The data cannot yet distinguish the 3. The British Survey's own modeler says on record that the pole could change its rate or accelerate again. The current map is built to hold until 2030. Whether it actually survives that long is itself the measurement to watch. The field has forced one emergency update already, in 2019, and it is under no obligation to respect the calendar twice. If a new model appears early, that headline will not be about cartography, it will be about the core. Number 2, the dent. The South Atlantic anomaly's slow westward drift and its depth read out through the satellites that cross it daily, and the field missions watching from orbit. It is the one place on Earth where the field's weakening sends a bill every single day, which makes it the most practical gauge of the shield's condition that exists. Number 3, the tug-of-war. The relative strength of the 2 great lobes, the fading one under Canada, the growing one under Siberia, in each new release of core field data, the pole goes where that imbalance says. The imbalance is measurable. Watch the contest, and you are watching the pole's future before the pole gets there. And number 4, the quietest of all, the dependencies. Every phone, aircraft, ship, and submarine on this planet recalibrating against the model, silently, on schedule, while air routes and shipping lanes push ever farther into the polar blackout zones where the map admits it cannot help. This machinery works precisely because it assumes the field will surprise it. That assumption is the entire design philosophy. The day it stops being honored is the day this story gets a very different episode. So test the title one last time against everything on the table. Did the magnetic pole just snap? Something did a trend. A 30-year sprint. unlike anything in 2 centuries of measurement, broke into the largest deceleration ever recorded, and nobody saw either coming. The pole itself, meanwhile, did exactly what a pole does. It moved, and the map moved after it. Is the shift accelerating? No, and the truth is stranger than that headline. The shift changed character, twice, in ways the best models on Earth could only follow at a distance. An accelerating pole would at least be a trend you could extrapolate. What we have is a pole that keeps rewriting its own trend, which, for a chaotic engine, may simply be what normal looks like. Which leaves the real danger, and it was never a flip arriving tomorrow. It is mistaking a 5-year map of a chaotic engine for a promise. 2019 was the rehearsal for that mistake. The year the planet outran its own paperwork, and the field will keep issuing corrections on its own schedule forever. The only open question is whether the maps keep up. In every investigation, this channel has run flares, typhoons, faults, oceans. That same race appeared. Here, it simply runs slowest and deepest, 2,900 kilometers down. So, watch the speedometer at the next release, watch the dent drift west, watch the tug-of-war in the core data, and watch the calendar through 2030, or until the field decides otherwise. We will be tracking all of it as it develops.